Hello everyone, today we'll be looking at how to factorize quadratics when the x squared coefficient, i.e. the number in front of the x squared, is not equal to 1. Now normally when we're first introduced to quadratics and factorizing of quadratics, we start with quadratics that may look something like this: x squared plus 6x plus 8. But today my main focus is on quadratics where the x squared coefficient is not equal to 1. So examples such as 3x squared plus 11x plus 6, and also introducing some negatives with 6x squared minus 7x minus 5. Now, if we look at the bottom two examples, it's quite clear to see that the x squared coefficient in the very last example is 6. In the one above, it's equal to 3. But there is also an x squared coefficient in the very top equation, or in the very top expression, which is 1. A lot of people don't realize this, but it is very important to note. And it will become very clear with regard to the methodology we're going to use when factorizing quadratics when the x squared coefficient is not equal to 1. The method we're going to be using today is something called the C method. Now, A and C we can see are represented by the letters over here and over here. They will be represented by numbers. And when you've got two letters next to each other in this manner, it means you are going to be multiplying. It's about the multiplication of those two values, and it's very, very important for what we will be doing today. So I'm going to start us off with a expansion of double brackets, because actually the first time most people come across quadratics, it's from this expansion of double brackets. Now there are many different methods which you can use to do this. Some people use a method called FOIL, others I've seen use a crab method, but I'm going to show it to you via a rectangle where you've got x plus 4 multiplied by x plus 2, x plus 4 represented by the length of this rectangle, and x plus 2 represented by the width. And we're just going to multiply this through to create these smaller little rectangles here with the areas within. So x times x is x squared, x times 4 is 4x, x times 2 is 2x, and 2 times 4 is 8. Now, whenever you expand a double bracket, you will always first start off with 4 terms. So if we write down our 4 terms, we've got x squared plus 4x plus 2x plus 8. Now, some of you may notice that this x squared plus 4x is simply x plus 4 times by x, or x plus 4 just times by the x. I can write this down as x brackets x plus 4, and I'll come back to that a little bit later because it's very, very important for what we'll be doing momentarily. The line below is 2 times by x plus 4, so the 2 multiplied by x plus 4, so I'm going to write that in as well, plus 2 brackets x plus 4. And this will be very, very clear in our later method as to why it is so important. So now the quadratic here hasn't been finished because we can still collect these middle like terms. I can add together this 4x and 2x to make the quadratic of x squared plus 6x plus 8. Now, when we factorize quadratics like this, when the x squared coefficient is not, or is equal to 1 in this case, we can see that these numbers over here, the 2 and the 4, they multiply to make the 8 over here. And 2 plus 4 adds to make 6. So normally what we do is we find what we call the product of two numbers, product meaning multiplication, which is equal to 8. And we find the combinations that add to make 8. So numbers that multiply to make 8 could be 1 and 8 and 2 and 4. 1 plus 8 makes 9, it doesn't make 6. 2 plus 4 makes 6. So that would be the method that we normally do. We normally go straight from this to this and put it into double brackets. However, what I want to do is to work backwards, follow this method back, because it's going to be very important when we come to quadratics when the x squared coefficient is not equal to 1. So the first thing we do is we split it back up. We go x squared plus 4x plus 2x plus 8. It doesn't matter which way we do this round. it's clearly up to you. You can write it as x squared plus 2x plus 4x plus 8. The method will still work. Now, if we go from this line to this line, what's happened is this has had a factor of x taken out from this x squared plus 4x. And this has had 2 taken out from 2x plus 8. So what we do is we factorize these in pairs. And this is always the case. You factorize the two pairs separately. When we look at the first one, the thing that's common to x squared and 4x is the x. So we're left with x and x plus 4. Over here, we have a factor of 2 that can be taken out, 2 brackets x plus 4. And we notice that we end up with the same thing over here and over here. If you don't end up with the same thing, you've made a mistake. And it will be very, very clear when we come to negatives that that can happen sometimes. You have to be very, very careful. You need to end up with the same thing over here and over here. Because now what we can see is that x plus 4 over here is common to both of these terms. X plus 4 is in this term and in this term. So if I take out a factor of this x plus 4, over here I'm left with just the x, and over here I'm left with this plus 2. X plus 4, x plus 2. We've got exactly what we had right back at the beginning, and that is now factorized a quadratic using that slightly more complicated method. So what we've done is we split up the 6x into 4x and 2x, and then from there we factorize these in pairs. Now this gets a little bit more challenging when we start to introduce x squared coefficients that are not equal to 1, but it still follows a very, very similar principle. Over here, I'm just going to expand this one quickly. We've got 3x plus 2 and x plus 3. 3x times x is 3x squared. X times 2 is 2x. 3x times 3 is 9x. And 2 times 3 is 6. Those are our 4 terms. If I now write those out underneath, we have over here 3x squared plus 2x plus 9x plus 6. And once again, we can collect those two like terms in the middle. And once we do that, we get 3x squared plus 11x plus 6. Now, some of you may notice an issue here. Previously, we said we need two numbers that multiply to make the 8 and add to make 6. If we try that over here, we take this value over here, p is equal to 8, p is equal to 6. The combinations of 6 are 1 and 6, and 2 and 3. Neither of those add to make 11, so we've got a problem here. However, we said we're going to call this, or we can use this method called the AC method. Things have changed because of this 3. Now, if we go about this again, and I write down the product is not going to be 8. Over here it was 8, but actually it's 8 times by the 1 over here. 8 times 1 is still equal to 8. Over here, if we use what we call the AC method, the product is AC, which is 6 times 3, or 3 times 6, which is 18. We're now looking for two numbers that multiply to make 18 and add to make 11. This is why we called it the AC method. It's not just two numbers that multiply to make 6, it's two numbers that multiply to make 6 times 3. The combinations for 18 are 1 and 18, 2 and 9, 3 and 6. Any of those combinations could add to could multiply to make 18. We need the one that adds to make 11. 1 plus 18 is 19, 2 plus 9 is 11, 3 plus 6 is 9. So it has to be the 2x plus 9x. So underneath that, we write that out as our 4 terms, 3x squared plus 2x plus 9x plus 6. We now follow the same process we did before. We factorize these in pairs. Over here, what is common to 3x squared plus 2x? Just x. We are left with x brackets 3x plus 2. The one on the right, 9x plus 6. What is common to both 9x plus 6? Well, that is 3. 3 can be taken out as a factor. We're left with 3x plus 2. And we can see we've ended up with 3x plus 2 in both brackets, which means that we know that's going to be correct because we've got the same thing over here and over here. So to finish that off, 3x plus 2 with the x and the plus 3, exactly as we started with. So the only difference here is we first found the product being AC and not just being equal to 6. It's not 6, it was 6 times 3. So to finish this up, we're going to do 2 questions together with this method on the side so we can see it very clearly and we can apply it to our negative questions as well. First question at the top, 5x squared plus 22x plus 8. The product is equal to A times by C. 5 times 8, which is 40. We need to find 2 numbers that multiply to make 40 and add to make 22. So our combinations could be 1 and 40, 2 and 20, 4 and 10, 5 and 8. Now I've written them all down, you don't have to, but it's about finding the combination which you need. 1 and 40 adds to make 41, 2 and 20 adds to make 22x, that's what we need. 4 and 10 is 14, 5 and 8 is 13. So we know that 2 and 20 is the combination that we need. So we're going to split up the 22x, 5x squared plus 2x plus 20x plus 8. And we are now going to factorize these into our pairs. If we look at the very first pairing, we have over here, the only thing that's common to 5x squared and 2x is that x over here. And that leaves us with 5x plus 2. The thing that's common to 20x plus 8, what's common to 20x plus 8 is 4. So we take out a factor of 4, we end up with plus 4 brackets 5x plus 2. We can finally see that 5x plus 2 is common to both terms. So I can once again take out that last factor of 5x plus 2, and then we end up with x plus 4x plus 4. And that's it, that was the method. That's 4. We've used AC, found the pairing that multiplied to make 40 and add to make 22, split that up, factorized in pairs. Very last one now, we're going to finish this up. This one's a bit different. We've got some negatives in this, but we follow the same principle. The product is equal to 6 times minus 5, which is minus 30. Now this is different because you can get combinations with positives and negatives. If you're multiplying to get a negative term, you need one positive term and one negative term. So that means it could be 1 and minus 30 or minus 1 and 30. So we're going to have a lot of these different combinations. We could have minus 2 and 15 or 15 and minus 2. We could have minus 3 and 10 or 3 and minus 10. We'll notice that the one that adds to make minus 7 is 3 and minus 10. So if we write that down over here, if we split that up, we get 6x squared plus 3x minus 10x minus 5, and we factorize these in our 2 pairs. Over here, we look at what's common to both. Now this is not just going to be x, it's going to in fact be 3x, and that leaves us with 2x plus 1. Now over here, if I take out just a factor of 5, I'm going to end up with some negatives. So I actually have to take out a factor of minus 5. If I take out minus 5, I also get 2x plus 1. That gives us our final pairing, which we can see has worked out. We've got a common factor here of 2x plus 1, and that leaves us with 3x minus 5.